Okay, so it looks like we really are recording this time. Apparently, I thought we were recording last time, but we were not. So, I want to walk you through the earthquake lab. It looks worse than it is. There's a couple of labs like this. I'm going to go ahead and I'm going to log in. And let's go to GEO 110 and lessons. And let's go to earthquakes. So it does help to do the exploration. The big ones you're going to need to do is location of an earthquake and seismic waves. Make sure you really pay attention to these two. That's going to help you a lot. The next thing is you've got to install Google Earth Pro. You don't have to launch it yet, but it's got to be on your machine or you can't do the lab. Nothing else is going to make sense until you do that. Then we open our seismograph locations file. And when I click on it, Google Earth should open automatically. And this is what it looks like. So these points are part of the file. I've gotten some emails. They're like, oh, I opened the file itself. I saw something weird in Notebook. Don't open it with anything other than Google Earth. If you see these three dots, then it opened correctly. These three pins mean that it opened correctly. So I'm going to try and split the screen so we can look at the lab and this simultaneously as we go along. So zoom out until you have all three seismograph stations. This is good enough, but I could also hit control or go here and zoom out a little tiny bit. And now I really can see all three seismograph stations. Here, here, and here. So I've got Japan, Hong Kong, and Korea. So all three are visible. Then you're going to open the tools menu in the tools bar. And you're going to go to options. And you're going to make sure it's set to decimal degrees. And you're going to hit apply. So mine already is. You see in lat long, I already have decimal degrees. And I'm going to hit apply. And hit OK. Now you're going to go to the view menu. And you're going to make sure that you have your grid on. So if you don't see it, it's going to look like that. It's off. We want it on so we see those little boxes, those lines, basically latitude and longitude. Now click directly on the blue underline name for the three seismograph stations listed in places on the left-hand side of your menu. So if you do this, the seismograph, the seismogram should already come up. So for each seismograph station, there's a seismogram. And we'll talk a little bit about how to read this because it's a little intimidating the first time that you see it. But it's really pretty straightforward once you get used to it. So I'm just going to close that by clicking the X. And then you're going to record the latitude and longitude for each station. You don't have to look it up. If you go back to the seismogram, so here's our seismogram. It's down here in the lower left-hand corner. So for this one that I clicked, this is Hong Kong. It's 28.8 degrees latitude and 114.4 degrees longitude. Okay, so it's written right there. If you want east and west, you can zoom in. So it's north latitude, and east longitude. Now you're going to use the seismograph image to determine the P and S wave arrival times for each. So we're going to click on this. We're going to walk through finding the starts. I'm going to walk you through number one together, the first one. I'm just going to walk you through Hong Kong. And you can do the rest on your own. So we're going to click on the blue part here. So I see the seismograph. I'm going to blow it up. Where are those P and S waves? I'm going to go grab an Excel worksheet so we can have a place to put our data. I'm going to have it over here. Okay. You're going to enter it into your table. I'm going to just enter it here so we can see it. So we're gonna have Hong Kong. And we're going to have, once again, you don't have to do it in Excel. We're just going to, I just want to have it up on the screen so you can see it, because a lot of people were having trouble with that as well. Let me see if I can hide this. Where, go away, ribbon. I want the, anyways, I guess I'm stuck with the ribbon and it's making things more difficult, but be that as it may. Be that as it may, I'm going to do it like my computer can eat a potato. Okay. So where's the P and the S wave? So this little fuzzy at the beginning, that's just noise. That's not the P or the S wave. The P wave is the first boom shakalaka. The first, you see the spike and wave and then it decreases. So this whole thing right here is your P wave, okay? And so the start of the P wave is the start of that first boom shakalaka wiggle, 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 okay? Your S wave is your second wave. So that is this first boom shakalaka laka laka laka. See that? So that right in there, that's our S wave in here. And then we have our surface waves back here, but you only need the start. So this is the start of the S. These are our S waves. This is the start of my P. These are my P waves. Now, if that doesn't make sense, then you're probably going to want to make a little time with me. Okay. I'm happy to walk through any of this on Zoom or in person as people need it. So we are recording this time, right? I'm going to stop share for just a second and double check. It says we're recording. Okay. I just want to make sure this time, because this is multiple times I've been through this. Not your fault. Just want to make sure that's going well. Okay. So we have Hong Kong. I'm going to put P start and S start. These are the times we're going to put in here. Okay. Let me blow this up. See if I can make this bigger. I'm actually going to put this copy, put this in Word so I can really blow it up because I want people to see it. So we have P start and S start. I'm going to minimize this, minimize this. Once again, you don't have to do this. I'm just putting it up here so you can see it. Oh. And Word is being very unhelpful. So I'm just putting this up here so you can see it, and I'm zooming in so it's nice and big so you don't have to like zoom in. So we're doing Hong Kong, P start, and S start. So where is the P starting? So you have all these little dashed lines. These big lines are minutes, okay? So it's marked every 2 minutes. So this is 3 o'clock, 3:36 o'clock. Okay, so the big lines are minutes. So this is 3:32, 3:33, 3:34, 3:35, 3:36. Now there's 4 of these little hashes in between. So those are 15 seconds. So for example, this is 3:32, this is 3:32 and 15 seconds. This is 3:32 and 30 seconds. This is 3:32 and 45 seconds. This is 3:33. So we look at the 3:32 and it's 1 hash mark behind. So this hash mark here is 3:31, 3:31:15, 3:31:30, 3:31:45. So the P start is 3:03:31:45. Okay. Now I'm going to do the same thing with the S. The S is like right here. So it's 3:36, 3:36:15, 3:36:30, 3:36:45, and not quite 3:37. So I'm going to say 03:36 or 36 and 50. Okay. Now, once again, if at this point you're like, Dr. E, I am totally lost, then contact me. I'm going to delete these rows. Just so delete cells, delete entire row. So we're just looking at the data that we need. So that gets us, if you do that for each station, that already gets us right here, down here. So we're at latitude and longitude, and finding the start of the P and the S wave, that's number 11. Now, and we record it in table 1. Now we're going to calculate the difference in arrival times. So we need to subtract these two. That's giving us the difference. That's what we mean by difference. I'm going to extend this. And that means this is the bigger time, right? 336.50. So we need 336.50 minus 331.45. Okay. So we're going to subtract these two. So this one's really straightforward because 50, so 3 minus 3 is 0, 36 minus 31 is 5, so it's 5 minutes and 5 seconds, because the difference between 50 and 45 is seconds. Okay. Now it's going to be a little bit different if you might have to carry over a minute. So if you need help finding the difference in times, once again, I'm here to help. Another way you can do this, because we're just going to estimate it. Everything is being estimated. Another way that you could do this is even just count. So we're just before the 332. So we could count 1, 2, 3, 4, about 5 minutes. Okay. And about is all we need. That's all you need for this, is approximate. And so we can see there's about, it's almost 337. This is almost 332. There's about 5 minutes in between those two waves. That's another way that you could do it. Now we're going to use the seismic time travel graph. Whoop. And that's over here. So what we're going to do is we're going to try to find where there's a gap between the P and the S wave of 5 minutes. So the easiest way, I'm going to stop share and I'm going to show you on the screen how you would do this, because you kind of have to do this physically. There we go. Let's actually move this over to this screen so it's a little easier to see. So I'm going to start by finding how much is 5 minutes. And I'm going to do that by using this axis. This description is pretty lousy, but I'm going to try and show you the description in the lab. I'm going to mark 5 minutes. I'm going to mark it 0, make a mark at 0, and then go up to 5 minutes. So this is the size of the gap of 5 minutes. And I got that from the y-axis here. And I'm going to slide it up until I can find about a 5 minute gap. And that's right about here. And if I, right about here, and if I follow it down, it's about a 5 minute gap, follow it down, that's at about 3,500 kilometers. Once again, if this step you're like, I don't understand, Dr. E, I am here to help you. I have had very few students Zoom with me. I had way more students Zoom with me last semester. I don't know what's up this semester. But I'm always happy to Zoom or meet or that kind of thing. This is not supposed to be rocket science. This should be basic geology. It's just hard because I'm not in the classroom to help you over those little glitches that are really, really normal in any lab class. So, but I'm trying my best. So we got 3,500-ish. And so that's what, and they show it here. They actually give you a diagram here of what I just showed you on the screen, sliding it up and finding that measurement. And record that once again in data table 1. And then you're going to go to the circle generator. So for each one, you're going to plug in your latitude and longitude. You're going to get your circle radius, and that's your point name. So let's do the latitude and longitude. Latitude 22.22 or 28. Longitude 114.14. Circle radius 3,500. Let's see if that actually works without putting in the other ones. I'm just gonna do random numbers here. These are just random numbers. So I'm just trying to create something. Radius must be greater than 0. Fine. Do 10. Now we can download it. See, there's a little link down here. It says download. I downloaded it. We're just gonna roll with it. So that's my first circle. That's my circle around. Your circle should look like this. Okay. You're gonna do it for all 3 all at once, but your circle for Hong Kong should look something like that. So let's go back to the lab. And then you do the same thing for the other circles, and you name the circles, and then you're gonna go to you're gonna place a place mark. So a place mark, that's this little yellow icon in here, that's your place mark. You can, and so you're gonna mark your place mark. You can drop it wherever. So suppose the epicenter is there, that's where you could drop it. And you'll have a screen that opens up like this, and you can name it whatever epicenter location. And you're going to take a screenshot of your work. So there's a couple ways to take a screenshot. One of them is if you hold down, what is it? Yeah, we're going to escape out of that. If you hold down, if you're on a Windows machine, you hold down the Windows button, Shift and S, and you can just take a picture of the part of the screen that you want to take a picture of. And then, or you can save it here. Save image. And then, you would click Save Image here, and you select where you save it. If you're not used to navigating your computer, saving things to downloads can be helpful. And then you're going to upload your screenshot. And you'll run the hazards. And answer exercise 4 questions down here. So tsunami events, they're very little squares. I don't know why they did it that way. But for example, these yellow dots are examples of tsunami events. So are the orange dots. Let's see if we can see it. The red dots as well. Okay. So it's a little overlapping the Google Earth. It's not perfect. None of these labs are, but hopefully that gives you a better start. Remember, I am here to help you. I am always here to help you. So if you hit a point, don't be afraid to email me. Don't be afraid to call me. Don't be afraid to set up a Zoom. Don't be afraid to come down during my office hours. I am here to help. Okay. So I hope you have a good luck with your lab. I hope things go well for you. Thank you for watching this video, and please let me know if you have questions.